All right, so today we're going to talk about our goal, which is to solve equations with variables on both sides of the equation. So this will be the first time we've done that with variables on both sides of the equation. Okay, so before you can do this, you should be able to do two-step and these multi-step equations like this, because we're just going to build on that. So I'm going to go through one of these just to refresh your memory. For number one, if we are going to solve for x, if we're going to solve for x, we need to isolate that variable, get it all by itself. So the first thing we're going to do is we're going to try to get this term by itself because it has an x with it. So that means we have to get rid of this plus 3. And you do the inverse operation of subtracting 3. But remember, what you do to one side of the equation, you must do to the other to keep it balanced. So then you're left with 2x over here. And that equals 15 minus 3, which is 12. Now we're down to a one-stepper. And if you notice here that 2x on the left side, that 2x is actually 2 times x. So to undo that multiplication, you can either multiply it by 1/2, because that'll make it just a 1, or you can divide it by 2, because that's the inverse operation. And then you divide the right side by 2 as well. And you're left with, cross it out, you have x equals 12 divided by 2, which is 6. All right, and the way you check that, if you remember, is by plugging that 6 back in for x. And if you want to check that, we'll do that over here. Our check. That would be 2 times 6, because we're plugging that 6 in for x, plus 3 equals 15. Now you have to check to make sure this is correct. 2 times 6 is 12, plus 3, and that is equal to 15, equals 15, so we did it right. All right, that was a good check. Now these two on the bottom, I'm not going to go through the whole 9 yards with this, but I want to just start you off. So if you remember if you see this type of an equation, make sure you distribute first. So you see something that looks like the distributive property, and just do it to that one side. And if you distribute that 5 to the 2x and that 5 to the 3, you end up with 10x minus 15 equals 15. And now if you notice this, it's just a two-step equation where you can solve for the variable x. And then number 3 is you have to combine some like terms first. And if you notice there's two of them that have t's in them, keep this minus sign in front. So it's 3t minus 6t, which is, 9t minus 6t, which is 3t. So the minus 6 over here equals 6. And here we got ourselves a two-step equation once again. And I will let you solve for that one. So what's new for today is, as we mentioned on the goal, is that we're going to have variables, the same variable on both sides of the equation. So if we have this one right here, now don't be confused by the two different forms. I'm going to do this two different ways. And the first way I want to do is just the regular algebra. So we have our equation right here. I'm going to rewrite it. 3x minus 5 equals x plus 3. Now if you notice here, we do have the variables on the left side of the equation and the right side of the equation. But if you notice anything about solving equations, we always just have the variable on one side. We get x equals something. X equals a different number that does not have a variable with it. So what we want to do here is get just the variables all on one side. And you can do this either way you want. If you want to get rid of it, the term with the variables on the left side, or if you want to get rid of the ones on the right side. I'm going to get rid of the ones on the right side right now. And if you remember, like if this x was a 6, we just subtract 6 from both sides. But this is an x, so let's subtract an x, because that'll cancel out that x. We don't want it on this side anymore. But you have to do that to the other side to keep it balanced. So that'll nicely cancel out right there. And what you're left with on the right side is just a 3 over here. And that's equal to 3x minus x is 2x minus 5. And now we have ourselves a two-step equation. What we're going to do first is we're going to add, we want to get that x term by itself, so we're going to add 5 to the side to cancel that out. So we do that to the right as well. And this will cancel out right here. And we'll be left with 2x equals 3 plus 5, which is 8. Last step, you can either divide both sides by 2 or multiply both sides by that multiplicative inverse, which is 1/2. I like to do that too. Works the same way. These two will cancel out because it'll be 2 over 2x, which is just 1x. And you're left with x over here. And 1/2 of 8 is 4. So our answer is x equals 4. And again, you can plug that back in for the original equation, and it will work out nicely. So that's way number one, the way that we are used to doing. Now I wanted to show you one more way to solve equations. This is using algebra tiles. Some people this is a great visual. Some people this can be very confusing for. But I want to give you the option of being able to do this if you'd like. Okay, so we've got our box, and I just want you to imagine that these are our two sides of the equation, so we have equals on both sides. Now, if you look at the original equation, and I will erase what's on here. If you look at our original equation, we have 3x minus 5 equals x plus 3. So on the left side, we have 3x. So we'll bring, and what I'm going to do here is make this an infinite cloner. I will make all of these infinite cloners so that we can keep using it. All right, so we have 3x's over here. So this is our x squares. We don't know what x is equal to. All right, apparently that did not go together there. All right, so we've got our x's. We don't know what x is yet. We're going to figure it out. So we're going to get 3x's over here. And those 3x's are also accompanied by -5. And we're going to use our negative ones here. So -1 we have, -2 we have, -3 we have, -4 we have, and -5. So we have 3x minus 5. And on the right side, we just have 1x plus 3. So +1, 2, and 3. All right, so this is just a visual representative of our equation. We got to figure out what 1x is equal to. So we got to get rid of the x's on one side. And to get rid of the x's over here, let's say, we got to subtract x from both sides. So let's subtract an x here. And we'll have to do that to this side as well. Now the kind of cool thing about subtracting an x from both sides is that when you subtract an x from an x, they cancel out. So we can take these and delete them. And we can take two of these, the minus and the plus, and delete them. Now we're left with our 2x minus 5 equals 3, which is kind of the same as over here if we did it this way. 2x minus 5 equals 3. We're going to want to get all of the constants on one side. So if you look at the left side, we got to get rid of that -5. And to do so, we're going to add 5. So we're going to add 5 of these ones. That one right there, that one right there. They're going to all cancel these out. So if you add 5 to a -5, that cancels out and becomes 0. All right. Get rid of those. But we also have to add 5 over here to get it balanced. 1, 2, 3, 4, 5. Okay, we have 2x equals 8, which is kind of represented right here again. But what we have to do here now is cut it in half. So I'm going to move some things around so that we have this x right here, this x right here. I'm going to cut it in half. We have 1, 2, 3, 4, and we have 1, 2, 3, 4. If we cut it in half, we just want half of the left side, which is just x, and half of the right side, which in this case we would just say 4, and then we're left with x equals 4. All right, and that's how you use it, the algebra tiles, just to solve an equation. It's a great visual, but again, it's up to you. I want to give you the option of using the regular algebra or using the algebra tiles. They both work. All right, so I'd like you to try this one problem. You are welcome to try the algebra tiles, or you can just use the regular algebra. All right, so if you pause it and try this, go ahead. All right, so what we're going to do again, just like before, we're going to try and get this, these x's all on one side. So, with that being said, let's get rid of the x's from this side. Well, you know, why don't we get rid of them from this side? We don't want them on this side. How about we'll do it the opposite. So get rid of these 4x. We're going to subtract 4x. And to do that to one side, you have to do it to the other side. Meaning, if you go like this, you're going to subtract 4x here. This nicely will cancel out. And you're left with 4 equals 1. 1x minus 4x is negative minus 3x. Okay, so our x's are on one side. We have ourselves a one-step equation. So the first step is going to get rid of this number that's not with the x term. So this is a positive 1. Okay, the negative sign, this subtraction sign is after it, so it goes along with that 3x, so it's negative 3x. This is a positive 1. And to get rid of that, we'll subtract 1. Subtract 1 from here. You have positive 3 equals negative 3x. That cancels out. Now it's one step left. You may divide both sides by this negative 3 to undo that negative 3 times x, or multiply it by the multiplicative inverse, which is 1 over negative 3. We're going to divide by negative 3 this time. And again, make sure you divide by that whole negative 3. We're not undoing it with a positive 3, because if we're dividing, we have to divide by the whole number. And we're going to divide this side by negative 3 as well. Again, this nicely cancels out. You are left with x equals 3 divided by negative 3, which is negative 1. All right. And I will, if you want to use the algebra tiles, I will let you do that on your own. But you should get x equals negative 1 here. And again, it's very helpful to check your work. So plug it back in for here and for here, for those x values. So you'll get, if you check it, you end up with 4 times negative 1 plus 4 equals 1 plus negative 1. And 4 times negative 1 is negative 4, plus 4 is 1 plus negative 1. Negative 4 plus 4 is 0. 1 plus negative 1 is 0. And we are happy, because that is correct. So negative 1 is your answer. For any time that you're solving an equation, whether it's like this, whether it's, any kind of equation, I want you to follow these rules. So I'm going to leave you with this. Solving equations takes 5 steps. The first step is to check to see if there's anything that you can use the distributive property. So if you have parentheses, you might want to look to see if there's something that needs to be distributed. Okay, so first use that distributive property. That is very helpful to make it more simple. Step 2 then, combine like terms. So if you can combine any like terms, go ahead and do that. After you use the distributive property, see if there's any like terms on each side of the equation. So you can't combine like terms from one side with the other side. It has to just be all the like terms on one side, and then you can check to see if you can combine like terms on the other side. All right, that brings us to step 3. Get the variable terms on one side. This is what we did today. We don't want variable terms on both sides of the equation, just on one. And then we can get the other numbers as constants on the other side. Okay? And use the properties for step 4 of equality to solve. So you know how to solve 1 or 2 step equations. Solving is step 4. And then lastly, please check your work. Check your solution. All right? And you do that by plug it in, plug it in. So plugging in the solution for the variable in the original equation and seeing if it works. All right, so that's our lesson on solving equations with variables on both sides. I hope you achieved your goal for today. If you have any questions on this, feel free to do some research on it. Otherwise, until next time, have a great day.